after having fun and experimenting with a brass ashtray and trying to rectify a sinusoidal wave, we have come to this picture. And this is more or less what we have been observing on the oscilloscope. This is a picture we would like to have a mathematical expression for. And this is what I've tried to do, kind of simulating this image and translating it into mathematical formulas. And the thing what I imagine is that this signal can be modeled, can be simulated as the union of two signals, one of which is sinusoidal, the other one is elliptical. So as you see here, it is the second on the horizontal screen, which makes a clear difference between the sinusoidal signal and the elliptical signal. And this can be explained by means of the Fourier series, according to this formula here, where I would like to say this is a capital F, so f of x is equal to a0 divided by 2 plus the sum of two big terms in which there are coefficients like an and bn. And this is clear to those of you who know and are familiar with Fourier series. In this big expression here, we see a0 has this function here, has this expression, so it's a periodical, an integral from minus t halves to t halves of this f of x, and an and bn are also periodical signals, also integrals, and in them there is this f of x appearing. Who is this small f of x? This is exactly what I explained before. It's the union of two signals, one of which is sinusoidal, the other is elliptical. And this can be better explained if we consider half waves of a sinus with an amplitude of 2, a phase equal to 0 and a period equal to 1, which is followed by the half ellipse, which is as large as the space between the big humps here. Okay, so if we set these parameters and then ask MATLAB to help us, we can achieve an expression with points. That means the program compiles this f of x as a sum of elliptical and sinusoidal signals, and in the end we obtain such pictures where we can approximate the observed, the empirical picture with a mathematical function. And the more parameter we put in, the more accurate is our result. So in the end, you see the big F, okay, the big f of x we started from is the sum of many factors. And this can be displayed, as you see here, with 2 harmonics, with 5 harmonics, or with 10 harmonics. As I said, the higher this number, the more precise the final function.